All right, yeah. So last time I talked about a special technology. So it's called ORM, Object Relation Mapping. Yeah. The question. Yeah. So some of you may ask, why we need to use this technology? Yeah. So this technology is very popular in IT industry. Yeah. So the answer is very simple. We want to improve the efficiency of our coding and the productivity, save our time. Okay, that's the main reason. Yeah, improve our productivity in programming, coding. Yeah. So why? So let me explain. Yeah. Why this technology can help us improve our productivity. Yeah. So the reason is this. So let's think about, we develop a real world application for certain business. Yeah. So you need to work on your data, work on your business data, right? So you need to add new data, modify your business data. You do this kind of operations frequently. All right. So what's the typical way you do the business data? Here, let me describe it. Okay. Yeah. So here, let's assume, because here I need to use a concrete example to explain the idea, how to improve the productivity. Yeah. So here, let me use the Java as the programming language. Yeah. Because this technology is very popular in Java web programming. Java web programming, very popular. All right. So think about when we need to collect business data. Yeah. The user enter the data, we need to enter into our databases. Yeah. All right. So how do we collect data? Collect the business data. Yeah, here. When we start in our web applications, we need to use a well-designed user interface to collect user input data. Yeah. So collect the business data. All right. After data is collected from the user's interface, we know that's at the client side, right? Yeah, the data collected at the client side, web pages. So that's the data is from you collect from the client side. Then the data should be sent to the server, right? Because your database is at a server. In order to enter the data into the databases, you need to send the data from client to server. Okay? Yeah. So how to send the data from client to server? You need some special objects to carry the data, right? The data should be stored in objects. Yeah, objects. Yeah. So here for this Java, so typically we use Java beans to store and carry the data. Okay, yeah. So you send, yeah. And the other direction, you retrieve data and populate the data. You also use Java bean. So here the data. So you carry. So use Java beans. Yeah, Java beans just special type of Java objects. Yeah. Java beans, the objects should follow the Java bean specifications. Yeah, Java bean specification, follow certain rules. Yeah. List of rules. Yeah. Here I do not specify those rules. Just special type of Java objects. Okay, Java beans carry the data. So then, at the server side, in our Java programs, after we receive the Java beans storing the business data, we need to write the data into the database tables of our databases, appropriate tables of our databases. So what do you need to do? You need to retrieve data from Java beans first, right? After you retrieve data from Java beans, then you need to write SQL queries to insert or store the data into the appropriate tables of your databases. Here, look at the work you need to do. Retrieve data, then write SQL queries, run the SQL queries, and then to persist your data. So here we know because after we write data into the databases, we call it the data is persistent. The data is stored on the hard drive, so the data is persistent. So look at the work you need to do. Okay, so retrieve data, write data into the tables. So this work can be optimized, can be made more efficient through the ORM technology. Through ORM technology. Okay? Yeah, because if you use the ORM technology, this part of the work can be made automatic. Okay? Yeah. So here, improvement, data persistent. So here we're doing the data persistent. See? Yeah. Yeah. All right. So to do that, in order to make your data persistent, so we use the ORM technology. Then the conversion, the data stored in Java beans, then write them into the tables. So this conversion part becomes automatic. Okay? Yeah. Save you a lot of coding. After you set up, you do not need to write the code. Okay? For that part, coding, automatic. Okay? Yeah. Think about if you have large number of tables, each table you have many fields, how much work you can save. You can save a lot of programming work. So greatly improve your productivity, programming productivity. So you can do things much faster. So that's the reason. So this technology very popular in industry, especially in Java web programming. All right, now let's move to the next slide. How to do it? The configuration. We have two configurations. Let me explain the basic process for these two configurations. All right. ORM solution. Change the object relation mapping approach by the special mapping way. Okay? Yeah. So drop no object relation conversion. Yeah. So the original OODB idea, object-oriented databases, original OODB, no conversion, right? Yeah. Because in that technology, you just write the business objects directly into the databases, no conversion. Yeah. But we drop that. Yeah. The drawback, we know, the big drawback we discussed the last time. Yeah. But binary data, it's not easy to manage the binary data directly in the databases. Yeah. So we don't want to use that. All right, drop that feature. And then drop manual object relation conversion. Yeah. So if you use the usual RDBMS traditional databases, then if you do not apply the ORM technology, you need to do the manual conversion. That's a lot of work, too much work. Okay? Yeah. So you may need to spend hours or even days to do the mapping. Yeah. Yeah. So you waste a lot of time. Okay? Yeah. All right. So we drop that part, manual part. Yeah. We adopt, so the new improved way, yeah. Adopt automatic object relation conversion. Yeah. So how do we do it? Yeah. Let me give you the step-by-step description. Yeah. How do we do it? Automatic, yeah. Mapping, yeah. Object relation mapping. Yeah. So here I use this. Yeah. Definitely there are several tools. There are several such tools can do this kind of mapping. So here I just use commonly used way. So old technology, but pretty common in industry. ORM to Hibernate, Java framework, Hibernate. I use this as an example. All right. Sorry. Yeah. How it works, the basic steps. Set up a configuration file. When we start, you need to related first, you need to take care of the database connection part. Yeah. Connection. Yeah. So you need to provide the necessary information to connect to your databases. Yeah. So the setup, you use a configuration file to do it. Yeah. All right. So what's that configuration file? Yeah. In this configuration file, you need to enter database connection information and the locations of the mapping file. So what's that database connection information? Yeah. I mentioned before, URLs of your databases. Okay, URLs. Okay. Then username, password. Okay. Yeah. All right. Then so username, password. Okay, and also DB driver. Remember the last time we talked about DB driver. Because when you do the connection, you need to specify the driver name. So that information. And the location of the mapping files. So your Java beans, those objects, how do you want to map your Java bean properties to table fields? So the mapping files. What's the mapping file? XML files. Yeah. XML files. Yeah. Most of the time, yeah. Do the mapping. Okay. Yeah. From Java Bean properties to table fields. Set up. Okay. All right. Yeah. And so here, two possible ways. Most of the time we use XML file, but sometimes for relatively simple situation, people can also use the property files of Java. Java has a text file store the Java properties. So that's basically key value pairs. Okay, the property files, basically it takes the format line by line, each line for one property, one line for one property. Okay, so one property for one line. Okay, each line, the format is key. You need to specify property name as the key. Okay, property name as the key. Equal sign, equal value, the property value. So key value pair, key equal value, one line for one property, and so on. So you specify. So that's to enter the simple information. You use property files, because this format relatively limited. You cannot enter complex information. Usually you enter relatively simple information. For complex, relatively more complex, we need to use the XML way. Okay? Complex way. All right. So the mapping files, you need to do that. Then the mapping files, one mapping file for one table. One table, one Java bean, one-to-one correspondence. Then one mapping file. All right. Then you need to write mapping object, definition of mapping object. That's the Java bean definition. Java bean. Yeah. So here we mean the Java beans. Definitely you need to write a Java code. So Java beans. Store business object, information for the business object. All right. Then all the supporting files are generated automatically. After you provide this part, one root configuration file. So you have a root configuration file. Okay, set up. So this is the root top level configuration. Root configuration file. Also in XML, okay? Also in XML format. Okay. Other than that, then you have a list of mapping files, okay? Yeah. So mapping file we'll talk about here. XML files. So you need to prepare that manually. Okay? These files you need to type, enter. You need to, use, write the content manually. Yeah. Then Java Bean definitions you need to write manually. Okay. Although Java Bean, when you use IDE, so Eclipse or NetBeans or other popular IDEs, they have built-in tools allow you to generate Java beans automatically. So you only need to enter, your Java bean properties. After you enter Java bean properties, then you can generate Java beans automatically. Yeah. So there are some tools, so you can do that. Okay. All right. After you have that, then actually generating out Java bean, there is some, so even the Java beans, it can be generated automatically from here by the mapping tool. The mapping tool can generate. Yeah, because you have database tables. So the mapping tool will use your database tables to generate, and the mapping files to generate your Java beans. So that can be generated automatically, the Java beans. Because you have enough information already. Okay? You have enough information from table, from mapping files. Remember, the mapping file provide the property names Java Bean property names. So it's enough to generate Java Beans. Yeah. All right. So then it's ready. After that, that's the setup part, setup. After that, then you can just write your code, Java code. But so when you do it, when you do the query, so how to do the query? Query. After you do the setup, next, when you need to do the query, right? Query, now you need to use a special type of queries. Yeah. So you won't do the SQL queries, okay? The SQL queries, then, you cannot make automatic. So you do special type of query, you can make automatic. So the query, here, when we use the Hibernate as the example, so there is a Hibernate query language, it's called HQL. HQL. Hibernate query language, okay? So it's not a SQL, the HQL, right? So Hibernate query language, you use the similar syntax as the SQL, slightly different, but you apply on Java Beans directly, okay? Hibernate query language, you write your query statements on Java Beans directly. So it's not on table, so on Java Beans, okay? Yeah. So then, if you do that kind of programming, so then you do not do data copy, okay? So the data copy, conversion, all become automatic. Yeah. So that's the basic process. So here I just give you the basic idea. Yeah. All right. Yeah. So that's the first type, by configuration. The second type, basically the same, but the Java team, they want to make the configuration a little simpler. So they changed the XML way. Yeah. So the second way, these XML mapping files, these can be eliminated. Yeah. So they use Java annotations to do the mapping. Okay. The second way, use the Java annotations. Java annotation technology, at something. Yeah. So in your Java code, you type at, Yeah. So you provide necessary information after at symbol, to do the annotation. Okay. Yeah. Use this. In that way, you do not need to write the mapping files, right? Yeah. To just the alternative way. Yeah. Alternative way. Yeah. Because behind the scene, some special annotation processing tool will generate the mapping files internally, hidden. You cannot see those mapping files, but generated internally. Okay. Yeah. So then used for the mapping. Yeah. All right. So that's the basic idea of this technology. Yeah. So here, just to give you a general description, how people improve in the real world situation. People want to do the database programming in a more efficient way. Especially, you have a lot of data fields you need to work on. Okay? So you want to do this kind of routine things, because all the work, just the routine operations. So you want to do all these things automatic. All right, so we finish part C. All right, then let's switch to part D, the last part of module 2. All right, yeah. So before we start part D, I want to talk about one special feature of MySQL. One simple but very useful, very convenient feature in MySQL. So here, I go to the, W3 schools to show you the feature. This page, okay? The feature is called auto increment feature, auto increment field. In MySQL, in a table, sometimes we can use this special field with the property auto increment property. So what's that? Let me explain a little bit. Okay, auto increment property. Yeah. So very useful, very convenient, but very simple. Yeah. Yeah. But this feature is special in MySQL. So in other DBMS, you may not have it. Okay, yeah. Most of the other DBMS do not provide this feature. Okay, yeah. So in Oracle, no such feature. Yeah. All right, so let me explain this feature, useful, interesting feature. Yeah. So let me take this part and explain why it is useful. Okay, yeah. Yeah. All right. First, what is this auto increment key? Let me explain a little bit. Auto increment field, special field. Field, well, you know field, right? A column in a table, one field. And look at this. Auto increment allows unique number to be generated automatically when a new record is inserted into the table. All right, first sentence. Yeah. Second sentence. Often, this is the primary key field that we would like to be created automatically every time a new record is inserted. So let me explain these two sentences. Last time, I give you the description of key field, right? The key field, when we talk about uniqueness, data integrity, there is a uniqueness requirement in data integrity. Uniqueness, I give you the key field. The values of the field must be unique, so we call it a field, all right? Then, a table may have multiple fields. So a table, we have many fields, right? We have many fields, yeah. And we could have multiple key fields in a table. So the first thing is a table may have multiple key fields. Last time I also mentioned why we want to use key fields, because we want to speed up search operation. When you do search, if you have a key field, you do the data search with respect to a key field, it would be faster than non-key field, okay? Non-key field. So key field, when you do the data search, more convenient. Yeah. All right. So we have multiple key fields. Yeah. And sometimes we want to select a special key field to be used to identify the rows. So that one, the key field used to identify the rows, we make it a special key field So we call that primary field. Primary field is created to identify the rows. The main usage of the primary key field, identify the rows of the table. Yeah. 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 Many times you want to identify the rows, right? Yeah. So when you do the search, when you do the update, yeah, if you want to update the data, you need to identify the row first. You need to select the right row to do the update operation. So you need to use, if you have the primary key, more convenient. Yeah. If you do not have the primary key, then you need to find relatively complicated way to do the identification. Yeah. In our project number 2, we will do that. In our project number 2, we have 5 tables. In those 5 tables, the first 3 have primary keys, but the last 2 do not have primary keys. But we need to identify the rows when we do the data updates. Yeah. So then we need to do a little more work to identify the rows. Yeah. If you have primary keys, that's easy. You just use the values of your primary keys. You can identify the rows. All right. So here, this auto increment field, often it is used to be the primary key. Okay, the primary key field. People often use the auto increment field as the primary key. Yeah. Yeah. How do you use it? Yeah. So this table, you can see this table example, how people declare a field with this property, auto increment, the values of this field. It takes the auto increment property, look at this person ID, int, not null, yeah. The value cannot be null, yeah. In module 3, I will explain this null, special null value. It's very important in SQL, null value. So not null, yeah. So the value cannot be null, yeah. Auto increment, the value takes auto increment. By the meaning auto increment, yeah, you do not need to provide the value because it's automatically generated by MySQL. Okay, the value generated automatically 1, 2, 3, 4 consecutive integers automatically. Okay, the first time when you insert a row, it takes value 1 the first time. Second time, it takes value 2 automatically. Okay, you don't need to provide the value yourself. So very convenient. And why it is convenient in our real-world applications. Although it's simple, but so convenient. So in many situations, you may need to use this special field. So this field is different from other fields. Okay? So usually for other fields, you have the business meaning, right? Yeah. For other fields, what I mean, other than that auto increment field, yeah, other fields, their business meaning behind them. Okay, behind that. For example, first name, there is business meaning, right? First first name of your customers, right? Yeah. Last name, age, salary, all those fields, they have their business meanings. Yeah. But this auto increment field, has no business meaning. Okay? Yeah, so that's one special property. So it is used for identification of the roles. No specific business meaning, the auto field. Okay, yeah. So no specific business meaning. All right? Yeah. But think about, sometimes it's very useful in some situations. Yeah. It's very useful. You need this kind of feature. Yeah. Here, let me give you an example. Yeah. So under what situation it is so useful? Yeah. All right. So here, let me give you a sample project that I used before. Yeah. For example, yeah. So here we want to look at a simple example. So this is, we want to develop a web application, and so what's the content of this web application? It's called Math Question Bank. We want to run a web application that is used as a math question bank. Yeah. Store large number of math questions for students to practice. Okay? Yeah. So math question bank. Look, lagging. I noticed the significant lagging. Math question bank. Okay? Yeah. So in this math question bank, we need a table to store a large number of math questions, right? Large math questions. Think about it. We need to store large number. Let's imagine thousands of math questions in this table. Okay? Thousands of math questions. Do we want to identify those math questions in the table? We want to identify math questions in the table. Okay? We need to do this. Identify the math questions in the table. Think about it. How do you identify math questions in the table? Yeah. Or we ask this question. What primary key do you want to use? Yeah, we know. Usually we use primary key to identify the rows. Here, the rows, each row corresponds to one math question. Yeah. But what's the primary key, right? So you can imagine it's very hard to find appropriate primary key. From the business part, what's the appropriate primary key? It's hard to find appropriate primary key, right? Yeah. So in this situation, the best way is use an auto increment primary key. Okay? In that way, 1, 2, 3. Each question corresponds to one number, unique number, 1, 2, 3, consecutive integers as the ID of your math questions. Okay? Yeah. Then it's very convenient. So you manage your math question bank. You need to use this ID a lot. Okay? Yeah, think about it. In the real world situations, it's very common, we need to use the auto increment primary keys to make our business data access very convenient. Yeah. Here, just give you a simple example. Yeah. All right. So that's this auto increment feature in MySQL. Okay. Yeah. So it's a special feature with respect to the DBMS. Yeah. So when you change to different DBMs, you may need to do things differently. Okay. You cannot use the simple way to identify. So you may need to do relatively hard way in order to identify the roles. All right. So let's move to now part D. So here you can see we try to enrich our background knowledge before we do the database queries, because those basic knowledge useful. When we understand the queries better, internally better, the background knowledge is useful. All right. The first topic, D.1, virtual tables. Virtual table. Okay, so not a physical table, virtual. Yeah. So another concept. So we know the table concept, right? Table, we mean a physical table. Yeah. Because the data to be stored in a table is physically persisted in the hard disk. Hard disk. All right, but here there is a concept of virtual table. So what's the meaning of that virtual table? So in our database context, we have a name for this concept called a view. Here, this view is a special name for this virtual table. So we call it a view of a database. View. What's the meaning of view here? It's a virtual table. Okay? The view here means virtual table. So let me explain why we need it. Why we need it. So there are some reasons we need this concept. Different users may require different perspectives on the same set of data. Now, think about our users' needs. So we write a web application to support our users' needs. And imagine we have a large user community group. So in this community, different users, they have different needs. So here, so when we look at our users' needs, okay, all data come from the same database. So the data for all these users, data from the same database. For example, for UMSL students, faculty in UMSL, that's the community, right? So our community, okay? And different users, you have different needs, right? Students, you have the student, faculty needs, okay? So when the data is retrieved, presented, then for different user groups, then the way to present the data should be different, right? Think about that, okay? The way to present, to display data format data, presentations should be different. Yeah. Then think about if same data but presented in many different ways. So here we are talking about a typical data presentation, a typical data presentation for a special group of users presentation. Coming from multiple tables, okay? Table 1, Table 2, Table 3, and so on, okay? Table N, let's say, okay? Because in order to prepare some special type of data presentation, you need to retrieve data from multiple tables, okay? Then you show the query results after you access multiple tables. But that's just for one group of users, right? For the second group of users, then you need to do a different presentation using data retrieved from different tables and so on, okay? Yeah. Think about for all those different data presentations, do you want to use temporary tables to store all those different presentations? You don't want to use temporary tables, right? Because then you may need to create too many tables. And the data for those different presentations, they are derived data, right? They are not original data because you retrieve from the multiple tables from data. So the presentation data, they are derived data, not original data, right? Yeah. But because those different presentations are used frequently, so we want to store those special presentation ways. So we want to store them, but we don't want to add too much redundancy. Here we need to use redundancy, but we don't want to add too much redundancy. Okay? So we want to control the redundancy. Okay? Yeah. So here there is a smart idea to do it. We use virtual table to manage all these different presentations. So here, that's the reason. Yeah. So those relational database designers, so they come up with the solution, virtual table solution, to solve this particular problem. So efficient way handling data. Yeah. So the virtual data. Yeah. Virtual means we do not store the derived data on hard drives. Yeah. We do not. So, or initially we do not store. Okay. Later, if you really want to store, you can store. Okay. But initially, we don't store the derived data. Yeah. Only when you have good reason, then you can store. Okay. So if we just want to use the same presentation again and again, we do not need to store the derived data explicitly, physically on the hard drive. Okay. Yeah. So how do people work on the virtual data? All right. So first, no physical storage for the data. Do not do the data persistency. Okay? Do not persist your data. Okay? Do not persist your data on the hard drive. Okay? Yeah. Because you only need to show the presentation result and the way to generate the presentation. You need to store the way how to generate. Okay? How to generate the data. So you need to tell DBMS how to generate the derived data for this particular presentation. Okay. All right. So there is a special way. So we will get there. Yeah. So it is derived from physical data. Yeah. Virtual data, not physical data. Okay. Yeah. So we do not persist them on the hard drive. Yeah. So we can save storage space. Yeah. But we need to describe how to generate using the SQL statements. Yeah. So you use SQL statements to tell the DBMS how to generate the virtual data. Okay? Yeah. So then you write SQL statements. So how to do it? Yeah. You write SQL statements use the syntax like this. Create. Yeah. So like create table. But you change the table to the view. It's not table. This time is view. You replace the table keyword by view keyword. View is a keyword. Okay? Yeah. Just like a table, similar to table, but you replace table by this view. Then the remaining, how do you define a table? You use the same way to define your view. Only difference between virtual and the physical is the name from table to view. You know how to define a table, right? Yeah. But when you want to define a virtual table, you just replace the table keyword by view keyword. Then the remaining syntax exactly as the table definition. Yeah. Pretty simple. Yeah. That way. In that way, every time when you run the query, yeah, so when you want to generate the data in a view, yeah, so it's virtual. Because the data by default, it is not stored physically on your hard drive. Yeah. But this last thing could be stored physically if needed. Yeah. So in general, people don't want to store physically. Yeah. But for some very special situations, yeah, some virtual data extremely important. Okay? Yeah, extremely useful. Yeah. Yeah. So you want to keep the data permanently on the hard drive, then you can save the data on the hard drive by another command, SQL command, persisting. Yeah. All right. Yeah. So that is this concept. Okay. Yeah. Yeah. All right. Then another concept: size of database. Of a database. In general, what is the typical size? Yeah. The storage space used for a database. How large? How much storage space could be used for a database? Now let's look at this question. The general answer for this question: a database can be of any size and no limit, any size, complexity. Okay? Yeah. So no limit, that is within the DBMS. When we say no limit, within the DBMS, no limit. Okay? No limit. Okay? Yeah. But you always have a limit, right? Yeah. Within the DBMS. DBMS does not put a limit on it, on the database size. So that's the meaning. Okay? Yeah. All right. Yeah. Well, so what I mean for the powerful DBMS. Yeah. Yeah. But some DBMS may put a restriction. Yeah. So DBMS may have a restriction for So MySQL and Oracle, no limit. Okay, so for the big players in the market, so the MySQL, so yeah, you know, for big ones, okay, for big ones, okay. For some small DBMS, then you have a limit. Okay, all right. So MySQL or Oracle, no limit. All right. Yeah. For Microsoft Access, we know it's a personal DBMS. Yeah. Not supposed to be used for large group of users. No. So for relatively small group of users, then there is a specific limit for the Microsoft Access databases. Okay, 2 gigabytes, that's already pretty good, right? For a personal business, family business, personal family business, yeah. So the business data you use, up to 2 gigabytes, because you can do backup, right? The history data, if you need more space, so you can back up most of the lot of history data, in your backup files, backup database file. Okay, so your current database, you only need to maintain the business data for most recent years, right? Yeah, in that way, so 2 gigabytes should be good enough. Okay, yeah, the backup, yeah, in order to access business data from many years ago, yeah, so it takes some time. Yeah, so you can, you can find it. It takes some time to find it in your backup files. All right. Understanding query. Yeah. In narrow sense, what's the meaning of query? So here, what I mean the word of this query. Yeah, when we talk about query, what's the specific meaning of the query? Right? Yeah. So in different contexts, the query meaning could be different. Even in our database context, different locations, different places. Yeah. So you need to look at the environment when you use this word. In the narrow sense, first, narrow sense, not the broader sense, data retrieval. When we retrieve the data, that operation, the query for that operation, data retrieval operation. Yeah. So that's the query. Okay, but it's a narrow sense. Yeah. So there is a broad sense. A broader sense, what's that? So any database access, including modified data, yeah. Modified data you can call it's a query. Okay, yeah. So in a broader sense, you can call a, insertion operation, update operation as the query. Okay, so it's not wrong. It is not wrong. Okay, yeah. All right. Yeah. Next topic, D.2. More on stored procedures. So let's look at some more properties for the stored procedures. All right. Situations here. Resources are distributed on different machines. Here we talk about a large web applications. So because one application, we need to support customers over the world, the whole world. So we have a huge web application we need to run in the whole world, supporting the customers from many countries in the world. Okay? Yeah. So you may need to use your web servers in many different locations in the world. So you have a distributed version of your web application. Yeah. So your web application, you need to, use many different web servers. Yeah. Yeah, web plus DB servers. Okay, so many web servers and DB servers in the world. So so they are connected. Okay, so they're all connected like that. Okay, all right. Then your web applications also distributed among those web servers. So that means for different location, the server location. So they may, when you write a code, so the code may do different modules. Here, for simplicity, I just say module 1, module 2, module 3, and so on. Okay, yeah, and so on. So module N, yeah, so many different modules. So those modules are connected, assembled together to form a big web application. Okay, so that's the architecture we are talking about here. So here then, we use the stored procedures in this distributed web application. So web application programs are on all these web servers. All right. DBMS is running on a database server. So let's say, suppose this is a DB server. The one in the middle, DB server. Okay? Yeah. All right. Provide data services for all other web servers. All right. An efficient way, actually I talked about this idea before. An efficient way to support all those different modules. And these modules, they may use different programming languages. Different programming languages. Right? Yeah, it's very common. Okay? Different programming languages. Okay? Yeah. So this kind of architecture, so there is a special name for the architecture like this, called microservices. Currently also very popular in IT industry. So the architecture for this type of web applications for the micro services. Okay? Yeah. Now, provide a lot of flexibility to develop large web application, microservices. All right. Yeah. Then, when we store the procedure in this situation, so specifically for the stored procedure, yeah. Remember, when you write the function definition, we know stored procedure, basically the structure of the stored procedure has functions, right? But we use SQL statements to write functions. But when you write those functions, there are two ways to write those functions. One way, you declare your function as procedure. Yeah. The name of your functions, the keyword you use, procedures. When you use procedures, no explicit output. You have input, you need to provide the input for this function, but you do data processing. You do not need to produce the output. Just like our C, C++ void function, right? The function in Java also, void method, the void function. You do not need to produce output, the void case. Okay? So the output type is void, right? Yeah. Yeah. But here, when you use the keyword procedure, you have this special way. If you want to return data, if you want to produce output, then you need to use the keyword, the function as the keyword. Not procedures. So you define function. So these two different ways when you write a definition of your stored procedures. Yeah. So the detailed, concrete way, later I can show you some examples, simple examples. All right. The properties for these topics. Store, because with this special situation, store and execute by DBMS and database server. Yeah, so here. When you do in this way, then all those different programming languages, they can share, they can call the same set of stored procedures in that DB server. All different programming languages, we just call stored procedure, remote stored procedures, remote call. Different programming languages, you do not need to use your own language to write the logic definition of the data process. We just call stored procedure in the remote DB server. Okay, yeah. So more efficient. Yeah. So only one SQL version of the data processing process, so that can be used by all other different programming languages in your web application architecture. All right. Created in DBMS or in application program. Yeah. If you want to create, you can create either in DBMS. No. So with the definition, right? So you'll execute the SQL commands in your DBMS. So one way to create. Another way you can create in application programs. So at one place you create in your application program you created, then all other different programming languages, modules, they can consume this set of stored procedures after you create it at one place. So also, very convenient. Yeah. All right. All right. Called in, so when you call them, very simple. Each module, we just call individual stored procedures when you need them. All right. So that's the, general ways people use stored procedures in the distributed web applications. Because in this situation, distributed web applications, the stored procedure becomes more useful, more efficient. All right. So, circumstances using stored procedures. Typical cases. A database program is needed for several applications. Those applications could use different programming languages. Okay? Application could use different, so reduce duplication effort. You do not need to, do basically the same business logic in different programming languages. Only need to do once in SQL. So reduced duplication of effort. So one advantage. Another, improve software modularity. Those different modules, different locations, improve the software modularity. Okay. All right. Reduce data transfer communication cost. Because you do not need to send intermediate results. You only need to send a final result. So you reduce a lot of internet traffic. Internet traffic to send intermediate result, that's not necessary. Okay? So you complete the whole data processing work in one location. Then you just send the output, the final output, to different modules. So reduce the data transfer communication cost. Do not send intermediate. Only send the result. Access data without giving out too much permission. So that's another advantage. So this is, let me just last minute talk about this. Access data without giving out too much permission. Because some of the tables could be restricted by many other users, programmers. Okay? You do not have the privilege to access certain tables, but one person who has the privilege to access some special tables, that person can write a stored procedure to be called by other users without privileges, right? That's another good reason to use. Because you do not, so in the stored procedure, you only need to produce the aggregate information. Then, so you allow other users without privilege to access. Okay. All right. So let me just stop right here. So the next time we will finish this part, quickly. So we cover most part. All right. So then next week we can start module 3. So in module 3 we will practice SQL queries. Okay. So we spend most of our time working on SQL queries. All right. That's it.